Assalamualaikum and hello doctor. My name is NAJWA IZZATI binti KAMALUDIN and my matric number is CE180026. So as you can see here, this is my house plan, and inside the house plan there are ceiling LED lights, ceiling fans, switches, wall fans and ceiling lamp. So next, this is the table for the socket outlet and the load that is related to the MCB. So this is the list of the loads and socket for bedroom number 1, bedroom number 2, garage, living room, hall, bedroom number 3, dining room and kitchen. Next, this is the single line diagram. So as you can see, this is the single phase from the natural line into the meter to the main switch of 40 amp. So as you can see here, this is from MCB of 16 amp for go to number 2 with 4 loads of 3 lamp 1 fan, 16 amp to number 3 with 3 loads of 2 lamp 1 fan. Then MCB for 10 ampere to number 4 of 2 lamp 1 fan, 10 ampere of number 5 for 4 lamps 1 fan, 2 ampere to number 6 of 1 lamp 1 fan, 20 ampere for number 7 of 1 lamp 1 fan, 20 ampere for number 8 1 lamp 1 fan, and 20 ampere for number 9, which is for 2 lamps. So down here is for the socket. So as you can see, for MCB of 16 amp to number 2 with 1 socket, 16 amp to number 3 of 1 socket, 10 amp to number 4 of 1 socket, 10 amp to number 5 of 2 sockets, MCB of 20 amp to number 6 of 2 sockets, then another 20 amp for number 7 of 1 socket, MCB of 20 amp to number 8 of 2 sockets, and 20 amp of number 9 to number 9 of 2 sockets. So that's all from me. Thank you.
Assalamualaikum doctor. My name is NAJWA IZZATI binti KAMALUDIN and my matric number is CE180026. So as you can see, this is the distribution box of my house with the MCBs, and this fan is connected to the power socket right here. So I will be turning on and off the MCB. So as you can see, the first MCB is originally turned off, so I don't want to touch that one. So I will be turn off this one. So the fan is still on. Alright. Then I'll try the third one. The fan is also still on. Alright, so I will be turning off this one. Okay, still nothing happened. Then I will turn off this one. Nothing happened either. Turn off this one. The fan is still on. Then still the same. So when I turn off this one, so the fan turned off. So I will be turning on it again. So the fan turned back on. That's all from me. Thank you. Assalamualaikum doctor. My name is NAJWA IZZATI binti KAMALUDIN and my matric number is CE180026. So for the requirement of the last lab, I will be using just this MCB So as you can see, the light in the living room is currently on. Okay, so I will be turning off this MCB, and once it's off, all the lights are off too. So then I will be turning it on once again. So the lights is on. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is UZAIR SOOMRO, metric number AE19001. Okay, this is the house plan for the layout for the lab 4 MPE. Okay, in which this the house plan, there's a living room, room 1, toilet 1, store 1, dining room, toilet 2, room 2, kitchen, store 2, and laundry. There's the electrical plan for the light, fan, distribution box, and power socket. Distribution box is at the living room, and there are other places for the fan and lights. Okay, this is the table for the outlet circuit and the lot which occur in the lab 4, where there are the location which I use for the video, which is the dining room and also the living room, as stated in the video. Okay, for where I use the number 2 and number 3 MCB, miniature circuit box, for the tripping, where it occurs there's light is being off when I trigger the MCB off. And also for the dining room, when I off the number 1, the dining room light will be off. Okay, this is the schematic diagram of the single line, where there's power from utility pole and meter to the main switch and RCCB and the MCB for the other parts of the, from the MCB to the parts of the location of it occurs, where it triggers the lining of the electricity. That's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is UZAIR SOOMRO, metric number AE19001. Okay, this is for the final lab for MPE. Okay, as we can see, this is the circuit distribution board, DB board. This is the MCB for my house. Okay, for this one, this is the dining room. This one for the living room and store 1. And there are others as stated in the diagram. I will be using this two only, MCB1 and MCB3, for this video. Okay, as you can see here, this is the living room. The light is on. Okay, when I switch off this one, okay, the light is off. When I close the second MCB, okay, after I open, it open again. The lights open again. Okay, for this one, I close for the first MCB. As you can see here, the dining room lights off. Dining light is off. When I open this back again, it open already. The lights open already. That's all for from my video. For the living room and the dining room part, there's other for the storeroom and all, but the video will be longer. That's all for me. Thank you.
Greeting to my lecture. My name is Wong Chong, mentor number AE19007. So today I'll present my house plan. So in this house plan, we have the ceiling lamp, the wall fan, ceiling LED light, ceiling fan, door, switch, and socket. So next, this table shows the related MCB for lot and socket outlet. So for this house plan, we have 12 MCB with the related current 20 ampere and 10 ampere. So the location of socket outline or the lot is at the living room, kitchen, dining room, garage, and the bathroom. So here is the socket outlet and the lot with their respective MCB. So next, this figure shows the single line diagram for the electrical supply system in the house brand. So here with the single phase cut out and the neutral line, and we have go through the meter, main switch 40 ampere, RCD 40 ampere double pole for lining circuit and the power circuit. So we have the 20 ampere, the number 8 MCB, 2 lamp, 1 fan, 30 ampere, number 9 MCB, the automatic door, 10 ampere, number 10 MCB, the water heater, 10 ampere, number 11 MCB, 2 lamp, 1 fan, 10 ampere, number 12 MCB, lamp and 1 fan. So in this power circuit, we have all 20 ampere with the respective number 1 to number 7 MCB. So for number 1 to number 6, we have 2 sockets, and the number 7 is 1 socket. My name is Chong, entry number AE190007. So today I will show the electric circuit tracing for these 2 socket outlets. So we can look at this to the light, just turn on. So we put it here. It also turn on. So I will show the MCB control the socket outlet for 2 of these. So it's controlled by this MCB1. So basically we can see the lights turn off for both. So when it turn on, light will on back. So now I will show the electric circuit tracing for lining circuit. So here we have the water heater, the ceiling lamp in bedroom, the wall fan in the dining room, and the ceiling lamp in dining room. So we can look at here, the ceiling lamp in bedroom, wall fan in dining room, ceiling lamp in dining room. All is turned on now. So I'll show is controlled by the NCB. So it's this one, turn off. So you can look at here, 3 of them is turned off now. So it is controlled, 3 of this is controlled by that MCB. The water heater is the other MCB.
A very good day to doctor. My name is Wong sales matrix number AE180103, and today I will present my house plan for the lab 4 MPE, and this is the house plan same with the previous lab, and this is a legend. And next I will present the MCB. The MCB number 1 is 40 amperes and is on living rooms. It has 4 load and 1 socket load. You can see it has 1 socket outlet and 4 load at here that control the lamp, 3 lamp and the 1 fans. Next is the dining area. Dining area is 2 socket outlet. 2 socket, here is 1 and here is the other ones. Next, number 3 is also the dining area. It has 3 loads. At here you can see the lamp. This 2 is a lamp and this is the fans that controlled by the number 3 MCB. Next, the dry kitchen. Dry kitchen you have 1 load and 1 socket outlet. At here, 1 socket outlet and 1 lamp. Next is the wet kitchen. Wet kitchen you have 1 load is the lamp, and next is the storeroom. Storeroom you can see you have 1 lamp and 1 socket. That's controlled by the number 6 MCB. Number 7 MCB is 6 amperes. It is control the room, 2 lots, the lamp and the fans. And this socket is controlled by the number 9 MCB. It is 1 socket outlet at the room. And number 8 is the living room, 1 load at here. It is not same with this one. It is another 1 MCB. Next is the stair, 1 load at here. It is control the two-way lamps on the first floor. Next is number 11 MCB. Is control toilet, 1 load is the lamp here. Next, this is the single line diagram for the electrical supply system in the house plan. I will follow this table and draw this single line diagram. It is same with the previous tables, and it have a meter, and it have a main switch. And main switch is 63 amperes, And after that, you have a RCD double pole, and it's classified into two. One is the socket one is the load one, and it is same with the previous. That's all from me. Thank you.
A very good day to doctor. My name is Wong Chun Xiang's matrix number AE180103, and today I will present my MCB box and show the lamp and the socket. First, I show the lamp of the room. You see, this is the room. The lamp and the fans is working. And now I close the MCB switch. The MCB is this one. I close this one. You see the lamp and the fans is off. It's on, but there is no effect. In this section, I will show the plug to the MCB. You can see now it is closed. I'm on the switch. Now it's charging. Now I go and close the MCB. This is MCB. This one is for that. And the switch. You can see the plug is on, but the phone is not charging. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is SOOMRO. My check number AE190001, and for lab 4 MPE, last lab. Okay, for the I'm doing the question 55.1. The purpose of grounding electrical wiring installation. The purpose is to carry the electrical current only under short circuit or other condition that would be potentially dangerous. Usually it happens when there's a lightning, thunderstorm occurs. During that time the grounding is really benefit. Okay, electrical grounding is backup pathway that provides an alternating route for the current to flow back to the ground if there is a fault in the wiring system, and rather it go through anyone touching a dangerous appliances or electrical box. It facilitates physical connection between the ground and the electrical equipment and appliances in the home. And there are 5 main reasons for the grounding, which is important in electrical wire installation, which is the protection against electrical overload, in which it redirects it to the ground. Usually this occurs during the thunderstorm, lightning. Okay, and it helps to direct electricity to the earth to ground. It stabilizes the voltage levels because there's a high level voltage of being directed, and the earth is a great conductor. And lastly, it protects the person from getting damage, injury or death, which will be occur from the electrical shock if there's no grounding. Okay, that's all for me. Thank you.
So I will continue with question 5.2. Name 2 types of conduit that commonly used in electrical wiring. So first we have rigid metal conduit, RMC. It's a thick thread tubing, usually made of coated steel. Through it may be aluminium. It is normally used for high standard building because it has high resistance from mechanical impact. It can make the wiring more long lasting. So second, we have the rigid non-metallic conduit, RNC. It's a non-metallic unthreaded tubing.